Well, hey everybody, welcome back to the channel. This content is going to be part 2 on using your Arken Optics reticles for shot placement and or adjustments. So with all that said, let's get at it. Before we get too far into episode 2, I want to clear up a bit of a production error that I had in episode 1. In the first episode, in talking about the VPR and the VHR reticles, I was making the example that your reticle is a flattened version of your turrets. And in that content, I talked about a shot going to the left. And in doing so, I was actually holding on to your elevation turret. So I want to make something really clear so people do understand that your turret on this top of your scope is your elevation turret. And Arken does a good job. They have the word up on there, which tells you if you're going to turn it upward. And your turret on the side is your windage, or your left to right turret. There may be a bit of confusion in the first episode of this from the way I was trying to convey the example that your reticle really is a flattened out version of the turret, or the turret is a rounded version of the reticle. So with that out of the way, let's now start talking about shot placement and adjusting for the shot. Now, one of the cornerstones of precision shooting is using a consistent language with your shooting. And what I mean by that is if you have a MIL-based scope, you're going to want to convey your shots and your shot placement with MIL language. Just the same as if you have an MOA scope, you're going to want to talk about your shot placement with MOA language. And what I mean by that is if your shot was to the right, you may say, hey, that shot is 4 MIL to the right, or 4 MOA to the right, versus the language that we use in standard Kentucky windage type talk of, hey, your shot's 12 inches to the right. We don't want to speak in inches. We want to speak in either mils or MOAs. And we'll talk a bit more about that and why it's important and why it really does simplify things by keeping it very, very consistent. So let's go through our first example. Here we have our VPR reticle, and let's pretend there were a target in the background here, and you had a shot land right here. All right. So that shot is to the right. That right there, if you can see real well here, if my camera's focusing, is a 2. Now this is the MIL reticle. If you were to look through your scope and you were to move your center crosshair right onto the dead bullseye, so let's say the bullseye was back there and the shot was right there, and your friend asked you, how far to the right is my shot? Now you're not going to say 4 inches. What you would say is you are 2 MIL to the right with this shot. Just the same as if your shot were higher or lower if you had a shot down here somewhere. So right here, now this is where this Christmas tree on the VPR reticle comes in really handy for those precision shots in using all these subtensions. So right here, we would come down, we're at a 1, a 2, a 3, a 4, a 5, we're at the 6. So we're 6 MIL low, and we're gonna come over 1, 2, and we're 3 mils to the right. So if your friend asked you, where did I hit? You would say 6 mils low, 3 mils to the right. Now at that point, this is where you could either move your reticle upward and make the adjustment and aim. This basically would be your bullseye. Or this is where we actually would be moving our turrets to adjust for the shot. Now recall and keep in mind, if you turn your turrets, you're always going to have your bullseye as your center point of aim. If you use your reticle, you're going to move up your reticle and adjust for the shot. Now this, in simplicity form, is really how you're going to use your precision optic. Now the subtensions, now these very fine adjustments that you can do with your VPR reticle or even the VHR reticle are when it gets really tight and getting that really precision shot. Now you'll find a lot of people, a 1/10 of a mil with a click is close enough to get them where they want. But if you're in some kind of a competition, learning these subtensions and how many mils or how many MOA, the thickness of a line or a gap between a dash is going to help you get those precision shots. Which leads me to the next thing, a little bit more math. Now, before I get to some more shot examples or a little bit more math, I want to talk about one of the features that some people may not understand real well about these Arken optics. Now, these Arken optics are first focal plane, FFP. And what that means is as you change this magnification on your scope, your reticle dimensions are always going to be consistent. The measurements on your scope, on your reticle at 100 yards, at 200 yards, at 300, at 1,000 are always going to be the same. A mil is a mil. An MOA is an MOA. So when you look through the scope and you want to make that language conveyed to your friend, it does not matter the distance when you are conveying that language. So a mil is a mil and an MOA is an MOA. Always is the same with the first focal plane optic. Now, if you have the second focal plane scopes, which some of you viewers may have, generally there is one of the magnification settings that you are going to want to use for there to be a consistent and accurate conveying of that language. Some optics use 12, some use 8, some use 10. It all depends on the manufacturer. But most of your optics for precision shooting these days, and the affordability is there, are going to be first focal plane optics, and all of your Arken scopes are first focal plane. Okay, so the last little bit of mathematics that I'm going to touch upon in this series has to do with the distance that you zero your rifle at and the distance that you take shots at. So most of us zero our rifles at 100 yards in a broad sense. There are applications that we do shorter, and there's some that we do less, and there's ballistic things that, hey, this rifle's the same at 40 yards as 100 or 20 and blah. There's lots of those scenarios. But most of us zero our rifles at 100 yards. Now, something that I want you to keep in mind is shooting in ballistics are geometry. So the adjustments that you make at 100 yards to 200 yards are doubling, and 200 yards to 300 yards. So what I mean by that is if you have your scope and you take a shot and you're making a shot adjustment, well, the movement of your shot at 100 yards, let's say you're going to move at 1 click. Well, at 200 yards, the amount of movement, because it's twice the distance, would be twice the amount of movement. So for instance, just a vague example here, if 1 click at 100 yards was going to move your shot, in general Kentucky terms here, if 1 click was going to move your shot 1 centimeter, at 200 yards, that 1 click is going to be 2 centimeters. This is how this works. And conversely, if you were closer, if you took a closer shot from 100, it would be, say, 50 yards versus the 100 0, it would be half the centimeter. So that's the little bit of the last, I guess you could say, math that I'm going to talk about in this series, but it's something that you will want to keep in mind and start to learn a little bit more about. This is where ballistics come into play, and using a ballistic application and understanding your ammunition, because everything is not consistent with this as well. Things kind of change a little bit, but in a broad sense, understanding the premise that as the shot goes out, we're looking at kind of a triangle here. 1 click may be 1 centimeter at 100, it may be 2 centimeters at 200. So let's move on to more shot examples and see how you guys are with making an adjustment with a holdover in your reticle or using your turrets. Okay, so I'm at the gun range, or maybe I'm out west and I'm hunting mule deer and I'm with my friend who's taking shots across the ridgeline, across the valley. Regardless, I got a friend who's missing the target. So I'm gonna look through my scope and I'm gonna try to help him out here. So when I look through, I'm gonna see something like this. Now, I may be seeing shots in the dirt. I may be seeing shots on the cardboard backer of the target. But this is where I wanna see if you guys can figure out what the correct holdover would be and or turret adjustment would be on the scope to move the shot over to the bullseye. So let's check this out. Well, here are the two shots. We're going to call this shot 1. We're going to call this shot 2. Now, my printer didn't do a real good job of being able to print off the numbers on the reticle here. But let's see if you guys can look at this version and tell me what the holdovers would be for shot 1 and shot 2. So let me know in the comment section, what did you get for the holdovers or the turret cranking adjustments on shot 1 and shot 2? Because basically, in a nutshell, this is how you're going to use your Arken Optics reticle and or the turrets. Now keep in mind, again, your turret up top is your elevation turret. And to move the shot up, you're gonna turn, as the thing says here, upward or an increasing number. And your windage is marked right and left as you turn these knobs. Now the Arken Zero Stop is a great thing to have, and it's a really simple feature on these scopes that is awesome. Because what's gonna happen if you're not using your reticle for the holdover shots and you get to doing this and you're going all over and you're doing shot 1 and shot 2 and people wonder, what is a zero stop for? Well, as you do all this, you forget, how many times did I go around and where was the starting point? Well, the great thing with the Arken Zero Stop is, bam, it just stopped at my 0, and it's super simple to set up. So hey, with all of that, let me know, has this helped y'all? Are you that new guy that really hasn't known how to use these turrets or how to use these holdovers or how to use MIL or MOA language versus inches? Because again, if you're trying to help a buddy out and you say you're 12 inches to the right, he's not going to want to take his MIL scope and hold over on the 12. He's going to want to hear, hey, you're 4 mils to the right, so he can crank in, oh, almost did it again, production error, so he can crank in a 4 or hold over a 4. So hey, with that said, let me know in the comments what your holdovers were, and I always say, keep on shooting.